Okay, so we'll start. Why don't we start at the back and work our way forward? Okay, so this is the last things that we've done, volume and surface area. There should be no secrets about what is involved with those. Just to be clear, you're working in volumes of prisms. I've included cylinders and cubes and rectangular prisms, but cubes and cylinders because they are examples of prisms, aren't they? A prism, remember, is something we can slice and get a consistent area and shape. We should have our pens down. You'll get a chance to write this stuff down. You need to listen at this point in time. Calculators down too. Like, you don't need those. iPads can be face down at this point in time as well. Before that, we looked at similarity and congruence, and we had the proofs for similarity and the proofs for congruence. Congruence means that two shapes are the same size and the same shape. Similarity means that they are the same shape but different sides. You remember that we have different proofs for each one. For similarity, particularly with triangles, what have we got? There are 4. Both have got RHS. Both have got side, side, side. Both have got SAS. And the way that I remember this, because I forget this all the time, but I need a little bit of memory. With similarity, we need at least 2 sides for us to do any proof. And you'll know that one of the proofs for congruence is AAS. How many sides do we have there? 1. So is that going to be a proof for similarity? But we replace that with A. What types of shapes do they work for? Triangles. Very good. If I'm doing congruence, I'll replace AAA because we know that 3 angles doesn't necessarily mean they're the same size. I'll replace that with AAS or ASA. Sweet. That just tells you where the side is in relation to your angles. Cool. Now we need to know a few other angle rules to get us through that. Obviously we have our Z rule, our X rule. We need to know that the angles in a straight line sum to 180. We need to know that angles in a triangle sum to 180. All those sorts of things. Cool. The co-interior angles, they can be used at any point in time to prove congruence or similarity. We also need to identify the difference between, what can you tell me about these 2 lines? If I have a box like this, what can you tell me about those 2 lines?
Parallel.
They are parallel. They are not the same length, correct? But these 2 lines are the same length. Sweet. Now if those lines are parallel, what could you tell me about the angle here and the angle here? They're exactly the same. You could also say the same for the angle here and the angle here, correct? Which would also mean that that angle there is the same as that angle there. I've just proved similarity, correct? But I've got a side. If I knew another side, I could work that out. That'll do for similarity and congruence. Pythagorean trigonometry. What's Pythag? An old Greek dude. What did he say? C squared equals A squared plus B squared. There's something. What do we use these for? What type of triangles? Right angle triangles. C squared must always be, or C must always be the hypotenuse or the longest side. Speaking of hypotenuse, Pythagoras is always taught with, starts with T. Trigonometry. What is trigonometry? Synonymous with what little SOHCAHTOA? When we're using SOHCAHTOA, what must we ask ourselves? What do we have? And what do we want? That's the same for trigonometry, correct? When do we know when to use trig and when do we know when to use Pythag? When do we use Pythag? We're trying to find an unknown side and we have 2 sides, correct? When do we use trig? When we have or want an angle. When we have or we want an angle, we use trig. Sweet. That's term 4 in 6 minutes. That will make up the majority of your exam. It will not make up all of your exam. If I was to give you a here or there, I'd say about 60%. I don't exactly know. I haven't done the math, but I'm going to guess there's a little bit more of term 4, but there is still a fair bit of term 3 on there, so you need to know the topics of term 3. Let's work in reverse. I'm going to leave those up. So we're going